Example, let T be a linear map on finite dimension on a finite dimensional vector space we then prove that first one, R of t intersection n of t is equal to 0 element or theta element if and only if t square x is equal to theta. This implies tx is equal to theta. Second one, if r of t square is equal to rt, then r of t intersection n of t is equal to theta element. Solution. So let us start its proof. Before starting its proof, we should know what is r of t and n of t. We already know that r of t is nothing but the rank of the t, which is subspace of V, and n of t is nothing but nullity of t, and this small r indicates rank of t. This is range of t and this is rank of t. So for first one, let t be a linear map on a finite dimensional vector space. And for first one, it is question having if and only if condition. So we'll start with first part. Let intersection of range of t and nullity of t be theta element, that means 0. Then we have to prove that t square x is equal to theta implies tx is equal to theta. Now if we consider this, then we will prove this. So consider t square x is equal to theta. Again, t square x is equal to theta, so I can write composition of t and t is equal to theta. This can be written as composition of t of x is equal to theta. If I see tx as new element, then what we can conclude that t of this element is equal to theta. If t image of any element is theta or 0, then we can conclude that this element belongs to nullity of t. So from this we can write this t of x belongs to nullity of t, because nullity of t contain all those elements whose t image is 0. So t of x belongs to nullity of t. This also we know that t of x belongs to range of t, because if we are taking t mapping of this x element, then whatever we'll get as a solution will be the part of range set. So obviously t of x belongs to r of t. So T of x belongs to R of t and T of x belongs to N of t, this implies this T of x belongs to nullity of t and R of t. But this contain only zero element. So this implies this T of x is equal to theta. Thus t square x is equal to theta implies T of x is equal to theta. Hence first part is done. Now conversely let t square x is equal to theta implies tx is equal to theta. So we are assuming now this as true. Now we will prove that. To prove that intersection of rank nullity is zero element. So first we will consider any element. Let V belongs to, suppose, R of t intersection N of t be arbitrary. Here we are assuming that V is any element belongs to intersection of both R and T, R and N. Then if V is nothing but 0, then it will be proved that rank of T and nullity contain zero element. If V belongs to rank of T and N of T, this implies that this V belongs to R of T and this V belongs to N of T. Now, since V belongs to R of T, that is V belongs to range set, then there exists some U also belongs to V, such that T of U is nothing but V. If V belongs to R of T, then obviously there will exist some element U also belongs to V, such that T of U is equal to V. Now, U belongs to N of T. V belongs to N of T. This implies that T of V is equal to theta element. And if I am taking it composition with T, then T of theta. But T of theta is what? Theta only. And this become my T square. Okay, this is not V, this is V. So T of U is equal to theta. Taking composition with T both the sides. So T of U is equal to T of theta. Now this become my T square of U is equal to theta. Again we have T square of x is equal to theta. This implies T of x is equal to theta. So from here we can conclude that my T of U is also is equal to theta. If T of U is equal to theta, but T of U is nothing but V only, that is V is equal to theta. So we are assuming that the V is only we have chosen V arbitrary, and we are assuming that this V is element of intersection of R and RT and N of T. So V is nothing but 0. This implies that thus V belongs to R of T intersection N of T. This implies V is equal to nothing but theta. From this we can conclude that intersection of RT and N of T is nothing but set containing zero element, that is only zero element. So we have proved first part. Now for second one, B1, let rank of T square is equal to rank of T. Then we have to prove that rank of T intersection N of T is equal to 0 theta element or 0 element. Since rank of t square is equal to rank of t, so from this we can write, since rank of t square is equal to rank of t, so we can write dimension of range of t square is equal to dimension of range of t. Since both have same rank, that means dimension of range set is also equal to, here we are taking dimension of range because we have to find out rank of t intersection with n of t. Now by the rank nullity theorem, dimension of v is equal to dimension of nullity plus dimension of range of t. Since our t is mapping from v to v, so dimension of v is nothing but dimension of nullity plus dimension of range of t, and dimension of v is equal to dimension of n of t square plus dimension of n of r of t square. Since our t square is also mapping from v to v only. Now since dimension of v is equal to this and dimension of this v is equal to this, both are same, so from this I can write, if I compare both the part, then I will get dimension of n of t plus dimension of r of t is equal to dimension of n of t square plus dimension of r of t square. Now see, it is already mentioned that dimension of rt is equal to dimension of rt square, so we will left with dimension of n of t is nothing but equal to dimension of n of t square by 1. Both these are equal, so they get cancelled, so dimension of n of t is equal to dimension of n of t square. Now t of x is equal to theta. Taking composition with t, so t of tx is equal to t theta, but this is equal to t square x is equal to theta. Now since t is linear, we can write this. Now t of x is equal to theta implies t square x is equal to theta. This implies if x belongs to nullity of t, then x also belongs to nullity of t square. If t of x is equal to theta, then t square x is also equal to theta. This means from this we can conclude that this x belongs to nullity of t, and from this we can conclude that this x belongs to nullity of t square. Now therefore see, this x belongs to nullity of t and this x belongs to nullity of t square. This means this nullity of t is a subset of nullity of t square, and nullity of t square are subspace of v. Here this v means we are talking about domain, not codomain, because nullity is always subspace of domain and range set is a subspace of codomain with the same dimension. Therefore n of t is equal to n of t square. So here we have find out the dimension of n of t is equal to dimension of n of t square. Here we get nullity of t is equal to nullity of t square. Therefore if t square x is equal to theta, this implies my tx is equal to theta. Therefore from b part, by part A, we can conclude that rank range of T intersection with nullity of T is equal to theta element. So from all this calculation we find out this T square x is equal to theta implies T of x is equal to theta. So if this happened, then from part A we can conclude that the intersection of range of T and nullity is nothing but set containing zero element. Hence we have proved this example